Hi guys, I will explain moment of area part 1 from first moment of area to summary. Here I have a quiz for you. There is a rectangular cross section with this dimension 50 mm by 60 mm width and length. What is the first moment of area with respect to horizontal axis when the coordinate has its origin at the centroid of cross section? Number 1. 180,000. Number 2, 150,000. Number 3, 0. Moment of area is very important in mechanical engineering. Therefore, we need to understand every corner of its nature. This video covers from first moment of area and the second moment of area. The others will be explained in the upcoming videos. Why is the name called the first moment of area? Let's think about the area A and the force F. The centroid of area and the force F are the same distance d away from z-axis. The moment created by force F with respect to x-axis is product of force F and the distance d. Distance d is the moment arm. In the same way, the moment created by area with respect to z-axis is the product of area A and distance d to the 1, which is the first power. Therefore, it is not strange this term, the first moment of area. What is the first moment of area used for? The first moment of area can be used for locating the centroid of area. The first moment of area is defined as the value obtained by integrating the moment arm length y with respect to the entire cross-section. Let's take the coordinate system so that its origin locates at the centroid of a rectangle like in this picture. Rectangle is symmetry with respect to both of z and y axis. Then, small area dA is dz dy. This is the first step. The small area is distance y away from the z-axis. Distance y is the moment arm. Therefore, small moment dfzz created by small area with respect to z-axis is the product of y and the area to the z dy. This is the second step. We can get the total moment of area by integrating dfzz from minus dy to plus dy. This is the third step. The result of integration is equal to 0. It is valuable to remember that the first moment of area with respect to the axis passing through the origin of coordinate is always 0. Let's take a look at various cases for the first moment of area and the centroid. When the origin of coordinate locates at the centroid, the first moment of area is 0 in any cases as shown in these three cases. When the only one axis passes through the centroid, like in this picture, the first moment of area with that axis is equal to 0. That for the other axis is not 0, as shown in these two cases. When the origin of coordinate doesn't locate at the centroid, the first moment of area is not 0 with respect to both axes. The first moments of area are addable. All the moments of area can be added together after individual calculation with respect to the same reference axis. In this equation, dgz is the centroid of entire cross-section, both of area A1 and A2. This is the same as the relationship between moment, force, and the moment arm length. As you can see here, a resultant moment produced by all the forces can be expressed in terms of sum of all the forces and the equivalent distance dgz. Let's calculate the first moment of area for the practical example shown in this picture. We know the locations of centroids for each element A and B. By direct integration from dy to 2dy for area A and from 0 to 2dy for area B, we can get the final expression for area A and area B. Compared with the centroids of area A and B, each resultant value shows the product of area and the perpendicular distance of centroid to the reference axis. First moment of entire area, FGZ, is the sum of individual ones, FGZA and FGZB, which is 11/2 dz dy squared. Let's prove the first moment of area is the product of the area and the distance perpendicular to the axis from the centroid. In the picture, centroid of a rectangle is distance d away from the z prime axis. First, as usual, we calculate the small area dA and the small first moment of area dfz prime, integrating dfz prime from d minus dy to d plus dy, we can get the result, a product of area and d, because the area is equal to 4dz dy. Therefore, we have proved the first moment of area is the product of the area and the distance perpendicular to the axis from the centroid. I will show the derivation of parallel axis theorem. Here we have two coordinate systems, yz and yz prime coordinate. They are parallel each other. The yz coordinate has its origin at the centroid of a rectangle. On the other hand, origin of yz prime coordinate locates dy and dz away from that of yz coordinate. From the definition, we can calculate the first moment of area for yz prime coordinate. Y prime equals y plus dy. Therefore, we have two integral terms. The first one equals 0 because first moment of area is 0 when its origin is at the centroid. Consequently, we end up with this equation. Similarly, we can derive the equation for the other axis, y prime. This tells us parallel axis theorem that the first moment of area in the arbitrary axis is the area multiplied by the distance of a centroid perpendicularly from the reference axis. As an example, let's locate the centroid for some shape of two rectangles by referring to what we got in the previous slide. The perpendicular distance of centroids from z-axis are ay per element A, dy per element B. Therefore, we can express the first moment of area for A and B as shown in these equations. Then we are ready to calculate the global centroid for both of element A and B. The first moment of entire area should be equal to sum of two moments of area. Therefore, we can calculate dgy by this equation. Consequently, we can obtain the distance of centroid perpendicular to z, which is 11/10 dy. In the same way, we can find the perpendicular distance of centroid to the y-axis. We have the first moment of area for the element A as shown in this equation, and 0 for element B, because centroid of B rotates on the y-axis. Now, we are at the perfect position to calculate the global centroid for both of element A and B. The first moment of entire area should be equal to sum of two first moment of area A and B. Therefore, we can calculate dgz by this equation. Consequently, we can calculate the perpendicular distance of centroid to the y-axis, which is 3/10 dz. Therefore, the location of centroid is 11/10 dy 3/10 dz. From now on, I will explain the second moment of area. What is the second moment of area? For answer to this question, let's review the three consecutive slides explained in the previous video, E39. The beam will bend with curvature by moment m. Let's think about the small area, delta A, being y away from the neutral axis. Strain can be expressed in this equation, and finally be expressed in terms of curvature 1 over r and variable y. Therefore, stress can be expressed in terms of curvature and Young's modulus and variable y. Then, we can calculate the moment loaded on the cross-section. This is the moment equation for beam bending, loaded by small moment delta m. In this equation, y can be considered as moment arm length, which is perpendicular distance from neutral axis to the small area delta A, and the product of stress and area is a force. This is the moment equation in terms of stress, area, and the moment arm length y. We have two y's, one in the stress and another as a distance. Moment can be calculated by integrating this equation, except for y, others are constant. Therefore, we have integral term y squared dA. We call this term second moment of area because it comes from moment equation and including the second power of distance y. Here we have basic equations for calculating the second and the product and the polar moment of area. Let's start with the second moment of area, IZZ and IY first. The others will be explained in the upcoming videos. Let's calculate the second moment of area for a rectangle. By the definition, the second moment of area with respect to z-axis is integral y squared dA. As a step 1, we calculate the small area dA, which is b multiplied by dy. As a step 2, we calculate the small moment of area dIZZ. dIZZ is the product of area, small area dA and y squared. Therefore, the second moment of area can be obtained by the integration of this expression from minus h over 2 to plus h over 2. Consequently, we end up with be h to the 3 over 12. The answer to the quiz is number 3, 0. Here we have a summary. The first moment of area with respect to the axis passing through the centroid is 0. The first moment of area is defined as the product of area and the distance perpendicular to the axis from the centroid. First and second moment of area are defined with respect to the corresponding axis. They get bigger when the distance of centroid perpendicular to the axis gets bigger, and smaller in the opposite. If we watch the previous videos, you can easily understand upcoming videos. In the previous video, E38, I explained the principle to make in-plane and out-of-plane coupling stiffness elements equal to 0 based upon the sequence order of laminate plies. Recently, I explained how the unsymmetrical tire tread block produces the force per ply steer. The next video is ply steer 14, the moment of area, part 2. I will explain the second and the product moment of area and the parallel axis theorem. Please hit the thumbs up and catch the brand new videos by free subscription. So, what are you waiting for? See you in next video. Goodbye guys.